In this lecture, we're going to start to talk about the next type of macromolecule. So far we've talked about carbohydrates, and carbohydrates are what our body uses for energy, quick, usable energy. It's also structural, and we'll talk more about that later in terms of it can be used to help make the cell membrane. But what we're going to talk about today are lipids, and lipids are basically just another term for fats. So you are all familiar with fats, right? If I were to say name me some fatty foods, you probably would come up with some good ones like milk or ice cream or cheese, and these are all things that are good examples of fats. Oils are also an example of fats, so like vegetable oil, olive oil, those are all going to be fats or lipids. What are the jobs of fats in your body? Well, fats have a really important job, and they get a really bad reputation, I think. People try to avoid having fat on their body, and we need fat. Fat plays an important role in several jobs. So let's just talk about a couple of those. So one job is that your cell membranes actually have a fat component. You may have learned about this in your middle school classes about the cell, but it's called a phospholipid bilayer. That lipid refers to fat. So your cell membranes have a fatty outer exterior which helps protect them. I got news for you guys. Our skin is also made of fat, and that is one of the things that helps keep water in and also keep things we don't want out, right? So fat is really important in membranes. Also, energy storage, but this is not going to be fast like carbs. This is going to be long-term energy storage. So if you were to eat a bunch of carbohydrates, you probably know this already, but your body will convert that into fat if you don't use it, and it will store it for later usage. So fat is really important for long-term energy storage. And then finally, insulation. We are warm-blooded animals. We can produce our own body heat, which is really important. It's what allows us to function the way we do. It takes a lot of energy to do that, but we can create our own body heat. But one thing that fat does is it helps keep that heat inside, so we don't have to use as much energy, especially when it's cold out. What are the elements that make up fats? Well, it's almost the same. Well, no, it's not almost the same. It is the same as carbohydrates. The three elements that make up fats are carbon, hydrogen, and oxygen. And they also have a ratio, but the ratio is a little bit different. If you remember, in carbohydrates, the ratio of carbon to hydrogen to oxygen was 1 to 2 to 1. For example, glucose was C6H12O6, right? Fats are a little bit different. Fats do not have very much oxygen at all. So the ratio from carbon to hydrogen to oxygen would be 1 to 2 to almost 0. That little sign here, this little wavy symbol, that means almost 0. So, for example, if I were to take glucose, for example, I know this is a carbohydrate because it's a 1 to 2 to 1 ratio. An example of a fat would be something like this, where you have 55 to 110, so that's 1 to 2, and then oxygen, there are some oxygens, and oxygen does exist in a fat. You need some oxygen, but it's a very small amount. So that's a major difference between these two. It's carbon, hydrogen, and oxygen, but I know if I were just looking at these numbers and I didn't know what anybody was talking about, I would know that this was a carb because it's a 1 to 2 to 1 ratio, and I would know that this is a fat because it's a 1, that's a 1, to 2 to almost 0. So just make sure you're familiar with that. Okay, what else do we need to know about it? What is it made out of? What are lipids made out of? Well, the building blocks of lipids are really, there's 2 building blocks, but it's 4 pieces altogether. So the building blocks of a lipid are something called 3 fatty acids and a glycerol. What the heck is that? Well, let's take a look at a picture. I'll draw it. So we have, let me get this board back up here again. So if I were to draw what a fat looks like, if you think of fat, it's bulky, right? Fat takes up some space. So erase this. And if I were to draw a fat, it would have a structure that looks something like this. It has a molecule at the top called a glycerol. And a glycerol is just made up of carbon, hydrogen, and oxygen. That's what it's made of. It's got some carbon in there. It's got some hydrogens and oxygens. And then off of that, we have these things called fatty acids. And what a fatty acid is, it's very simply a chain of carbons with hydrogens attached to them. So depending on how many carbons there are, you're going to have hydrogens on the outside. So this would be an example of a fatty acid. Every single carbon has a hydrogen attached to it, like so. and then there would be 3 of those, right? So I'm not going to draw that out for all 3. But this would be a fat. So basically, this would be a lipid. You have your glycerol molecule at the top anchoring 3 fatty acids. So that's what a fat molecule would look like. It has a name. It's called a triglyceride. And you're going to hear that a lot in this section. Why is it called a triglyceride? Tri means 3. That refers to 3 fatty acids. And glyceride refers to the glycerol molecule. So a triglyceride just means 3 fatty acids attached to a glycerol. So if I were to ask you what are the building blocks of a lipid, the answer would be 3 fatty acids and 1 glycerol molecule. Let's go a little bit more into how some of the more breakdowns of what fats are. So let's talk a little bit about the difference between a saturated fat and an unsaturated fat. And that's probably what I'm going to finish up with this lecture today. So let's talk about a saturated versus an unsaturated fat. So saturated fats are going to be the ones that you want to avoid. And unsaturated fats are the fats that you want to try to eat. Those are the ones that are better for you. How can you tell the difference between them? Well, there's some major differences. Saturated fats, for one thing, are solid at room temperature. That's how you can tell if it's saturated or not. So think for a second of fats that are solid at room temperature. Butter, right? Crisco, if you've ever seen Crisco in your house. Steak, like if you cut the fat off of steak, that's going to have, it's solid, right? And then an unsaturated fat is going to be liquid at room temperature. These are going to be things like oil, right? So for example, vegetable oil, olive oil, sesame oil, whatever. It doesn't matter what oil you're talking about. If it's liquid at room temperature, that's going to be an unsaturated fat. But I do want to finish up this video today by making sure you understand the difference between saturated and unsaturated fats in terms of structurally. And it has to do with what they look like. So let's go through this real quick now. So an unsaturated fat, I'll do saturated first. So we have our glycerol, right? And then attached to our glycerol molecule, we have our 3 fatty acids. If I were to say the word saturated, right? We're going to start with saturated. I don't remember what I just said I was going to start with, but we're going to start with saturated. If I say I went outside, it was raining, and my shirt was saturated, it's totally saturated. What that means is it can't take any more water, right? Water's literally dripping off of me because there's so much water in my shirt, it can't hold any more. So something is saturated when it's completely filled. So what that refers to is how many hydrogens are attached to these carbons. So this would be, if I wanted to make this a saturated fat, every single carbon would be full of hydrogen. There'd be no missing hydrogens. And every single bond between these carbons would be single bonds. So it's all single bonds, and every single carbon is full of hydrogens. Can this molecule here, can this take any more hydrogens? Is there any room for any hydrogens? Well, you know that carbon can only make 4 bonds, right? And each one of these carbons has 4 bonds. So this would be a saturated fat, because it is a saturated fatty acid, and it doesn't have any room for any more. Let me draw an unsaturated fatty acid now. That would look something like this. So if I take a look here, and I start filling in my hydrogens, I notice that, oh, wait a second, there's a double bond here. So I can't put a hydrogen there. I can't put a hydrogen here either. And you get something that looks like this. And if you take a look now, not all of these carbons are completely filled. So this would be an unsaturated fat. And what that does is it actually allows it to bend slightly, and it makes it more pliable, which is one of the reasons why it's liquid at room temperature. But one way I could tell if it's a saturated fat or an unsaturated fat is a saturated fat over here is all single bonds, and every single carbon is completely filled. So carbons are full. They're saturated by hydrogen. So they're full of hydrogen. An unsaturated fat, on the other hand, this is a scenario where you have open spaces, right? There are double bonds that exist in an unsaturated fat, and not all carbon, right? Not all carbon is full of hydrogen. So just to finish up here, let's take a look at a couple more examples of that concept, right? So this top one here, this is the glycerol up top. So that's actually what glycerol looks like. If you're wondering what glycerol look like, it's carbon attached to a couple oxygens and a hydrogen. So there'd be 3 of those attached to each other at the top. And off of each one of those, you would have these carbons coming off in these tails. So this would be a saturated fat because there's all single bonds and every carbon has a hydrogen. This would be what is called a monounsaturated fat. Why is it called a monounsaturated fat? Because only one example of a double bond is there. So a monounsaturated fat would have 1 double bond missing 2 hydrogens. And then down here you could see something called a polyunsaturated fat. Poly means more than 2, right? Or 2 or more. So poly here would be, this would be a polyunsaturated fat because it has multiple areas where there are double bonds. Thank you very much.